Hello, pre-algebra. Mr. Lawrence here with your flipped lesson for today, February 6th. It's a Monday, and we are going to be moving into what is called the Pythagorean theorem. Now, look, if you're not getting the similar polygons, go back and watch the other video. Come to the help sessions. I know I was very proud of Caitlin Weeda and Kervin Hitton. They came in. They got help with their homework. You can't just blow through it. You've got to do your best on it. I guarantee similar polygons will be an important part of the OAA. And there's no reason any of you should not pass. You are too smart. If you give it your best effort, you're going to blow that test out of the water. You're too smart not to. All right, back to the Pythagorean theorem. The Pythagorean theorem only works when you're dealing with right triangles. Now, this is very important. Right triangles, not any triangle, a right triangle. In fact, if you know the movie The Wizard of Oz, near the end of the movie, when they give the scarecrow a brain, he incorrectly states the Pythagorean theorem. And only math people catch on to that, but he actually calls it an isosceles triangle. He's incorrect. It works with only right triangles. What the Pythagorean theorem says is that if you have a right triangle, hold on, let me draw one. I've really been practicing. Oh, look at how good I am. Oh, beautiful right triangle right there, ladies and gentlemen. You don't get to see those every day. All right. If you know the sides of the right triangle, at least two of the sides, you can figure out the third side. Okay, so for example, if I knew that this was 5, oh, I'm not in right mode. If you knew that this was 5 and this was 6, let's say inches, I could use the Pythagorean theorem to figure out this side right here. Okay. If I had a different right triangle, one that looked like this perhaps, and there's my right angle, and I knew that this was, say, 3 centimeters, and this was 6 centimeters, I could figure out that side. Okay, they're actually the same problem. But let's pretend that this time I knew this side here, and I'll give that side a name in a minute. I could figure out that. Now there's two different approaches to do it. The first thing you have to know is that this longest side of the triangle, the longest side of the triangle, the longest side of the triangle, the side across from the right angle has a very special name. The side across from the right angle has a special name. It is called the hypotenuse. Not the hippopotamus, not the thing you see in the zoo. This is the hypotenuse. All right, and this one here is also the hypotenuse. All right, the hypotenuse. When you go to use the Pythagorean theorem, it is very important to know which side the hypotenuse is. How do you find it? You draw a line from the right angle to the side opposite. Notice I did that. All right, the hypotenuse. The Pythagorean theorem states that if you square the two legs of the triangle, the right triangle, that will be equal to the square of the hypotenuse. Okay, now I've got to caution you. Mr. White, are you listening? I hope so, because sometimes kids think C is always the side you are looking for. It is not always the side you are looking for. It could be, but it doesn't have to be. C is always the hypotenuse. Always. C is always the hypotenuse. Always. So I'm going to set up how to solve the first triangle, and then I'll set up how to solve the second triangle. And you'll see they'll be done a little bit differently. The first triangle I will do in blue. All right. I know that this is side C. A and B don't matter. This could be A, that could be B. Okay, it doesn't matter. I'll call 5A and 6B. I'm just going to go and plug in. A is 5, so I need to do 5 squared. B is 6, so I'll do 6 squared. C, I don't know, it's x, so I'll call it x squared. Okay, now using my order of operations, I have to do exponents before I can add, so I will square to get 25 plus 36. That'll equal x squared. Now, 25 and 36, I believe, is 61. But that's not what x equals. That's what x squared is. How do I undo a square? Well, I undo a square by taking the square root of both sides. Okay? So, the square root of 61, I know as a ballpark, is going to be a little bit less than 8 because 8 times 8 is 64. The square root of 64 is 8. This answer is going to be in the high 7s, maybe a 7.8, possibly. Let's see what happens. I'm going to go to my handy dandy calculator and I will take the square root of 61. Oops. And when I do that, I get, rounded to the nearest tenth, 7.8. You should be able to estimate square roots like that if you know your perfect squares. So that means that C in this problem is 7.8 inches. Okay? Now that one will be very different than the red problem, the red triangle. So let me set that one up. All right. Well, again, I'm going to use a squared plus b squared equals c squared. That is the Pythagorean theorem. And this time, c is 7. Yeah, c is 7. How do I know? Because c is always the hypotenuse. Have I said that enough? Tony, were you listening? C is always the hypotenuse. Mr. Bliss, c is always the hypotenuse. Mr. Hevesy, what is c? Very good. I know you said hypotenuse. Raymara, c? Hypotenuse. You got it. I can't fool you guys. Now, A and B don't matter. I could call, this time I'll just for the sake of it, I'll call X B and I'll call 3A. It won't matter because when I square them and then add, it won't matter. Okay, so I'm going to fill in what I know. I know that A is, what did I say, 3? Yep, A is 3, so I'm going to do 3 squared. X is, B is X, so I'll do X squared. And then C is 7. I'll square the numbers and get 9 plus x squared equals 49. All right. My goal is to get x alone. Pay attention to this part, Omar. My goal is to get x alone. Well, there's an x squared alone, actually. I'm going to get rid of the 9 first, not by adding 9. I'm going to subtract 9. Did you catch that, Jocelyn? I don't want to add 9 to each side. I want to subtract 9 because 9 minus 9 will cancel out. 9 plus 9 will not. So I need one of them to be negative. All right, when I do that, those cancel. I end up with x squared, and that'll equal 40. How do I undo a square again? I'll bet you Kareem can tell me. To undo a square, I take the square root of both sides. All right, the square of x squared is x, because x times x is x squared. The square root of 40, well, I know the square root of 36 is 6. 6. The square root of 49 is 7. I know my answer is going to be somewhere between 6 and 7. It's probably going to be closer to 6 than 7 because it's closer to 40 is closer to 36 next to 49. I'm going to guess it's going to be about 6.3 or maybe it's like a 6.28. So I will take the square root of 40 and on my calculator it tells me it's approximately 6.3 and that is rounded to the nearest tenth. It ends up being like 6.324555532. Hopefully you're doing this along with me. And I'm not sure what units I'm in. I forgot. Centimeters. So B is going to equal 6.3 centimeters approximately. See how easy this is? This is easy stuff. All right. Let's set you up here. See if I can trick you. Drawing my triangle. Okay. And all right. Now we are going to use the Pythagorean theorem, a squared plus b squared equals c squared, to find the missing side. Well, first thing I'm going to do, does anybody know? I'm going to find C. I'm always going to find C first. I'm going to go to the right angle, draw a line, and the side I hit is C. So this is C. If you want, you can fill that in. Okay. A and B don't matter. This time I'll let this equal A, and it'll be B. So I'll get x squared plus 5 squared. I'll square everything. I'll get x squared plus 25 equals 289. Our goal is to get x alone. In this case, I need to get x squared alone first. I'll subtract 25 from both sides. So I will end up with, on the left-hand side, x squared, and that'll equal 264. And, well, I'm thinking that's a perfect square. I'm thinking that is 16. But let me check it. Let me take the square root. 264. Oh, no, it's not a perfect square. My mistake. I take the square root of each side. X squared will be approximately 16.2. And my answer was close to 16, but I was off a little bit. All right, 16.2. Now, let's look at a story problem really quick. Let's say that we know that a building is 40 feet tall. And we have a 50-foot pole that we want to put on the side of the building to help reinforce the wall. Okay, we're doing some construction on the home or building or whatever it is, and we're afraid that the wall might collapse, so we're going to lay a big pole against it. So, first of all, let me draw my building. And I think I said my building was 40 feet tall, right? Now, this pole leaning against the building, it's going to be leaning against the top and secured to the ground. Okay, and I said the pole was 50 feet long. Well, how far from the base of the building, the bottom here, how far from the base of the building do I need to secure the pole? In other words, that little black segment, how long is that little black segment? I want to figure out where I need to put the base of the pole so that when I lean it against the building, it's hitting the very top. All right. Well, do you see the right triangle? I hope so. There's a right angle right there. I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. Okay. Well, when I go to do my problem, the first thing I'm going to figure out is which side is c. I go to the right angle. I draw a line to the other side. And I'm going to get 50 squared. That's going to equal b. It doesn't matter. I'll call b x squared. And then a by default is 40 squared. I will square everything. I will subtract 1600 from each side to get x squared alone. When I do that, I'll be left with x squared, and that'll equal 900. And then I'm sure that Omar can tell you, how do you undo a square? You take the square root. So x will equal 30. So that means this is 30 feet long. So to put this pole down, I want to put the base of it 30 feet from the base of the building. And then, of course, I'll use a crane or something to lower it down very slowly and gently so I don't destroy my own wall. All right, that's the lesson for today. Mr. Lawrence signing off.